Okay, so I would like to share to you how to distinguish acidic, acidic, alkaline, and neutral oxide from the trend of periodic table. First and foremost, if we consider periodic table, right? So I have a periodic table here, like the only sketch, simple sketch of periodic table. All right, so I have a block S, two elements in block S, and then I have a block P, and then I have element in block D, and I have another block here, right? If you see your periodic table, then you can see we have another block of F underneath. So block S and block P, all right, are the main element in periodic table, while meanwhile block D are the elements that has different properties compared to block S and block P. Block D element, um, even though there are two atoms that cannot be said as a how do this one said as a transition metal, but basically these elements in block D is considered as the transition metal or transition element. It means that they have a different density, they have different melting point and boiling point. So for example, we have and let me pick one element from group two. Yeah, so this is actually group one, group two, and this is group three, and so on forth until group eight. Okay, so all elements um, of metal that located in group two, when you react with oxygen, it will create MgO. In the previous video, I shared to you that Mg is actually metal, O2 is actually non-metal. So when we have these two uh, atoms together, and then when they become ion, then they will have a MgO. If you're still confused, you just check. If you're still confused how to project this one, how to get MgO, go to the periodic table and then verify in which group in which group that Mg located. So since Mg is in group 2, therefore it will have a Mg plus 2, and then since oxygen in group 6, so it will have minus 2 charge. So finally you can get Mg. So you put this number diagonally. Yeah, you change this one. So Mg 2 plus goes to O2, and 2 go to from oxygen goes to Mg. So you now have Mg2 O2, but then because we have same number of atom, then you will have MgO only. All right. So now, how do I know the characteristic of this ionic compound? Right. So basically, we can see that MgO, all right, so MgO plus water. So when I add this alkaline to water, or basic oxide. Why do we call this one basic oxide? Because this is actually oxide that forms when you have metal, right? So reaction between metal and oxygen. So MgO plus H2O becomes MgOH2. Okay, so it becomes MgOH2, and then this one also will give hydrogen gas. Okay, so hydrogen gas. So it means that you have magnesium hydroxide, and then magnesium hydroxide is actually one of the strong base. Okay, strong base. It means that this base is completely dissociated in water, right? So what does it mean by strong base? Strong base is actually when we add this base into water, it will completely give Mg2 plus and 2OH minus, right? So this is actually aqueous, and this is actually aqueous. So when you have complete dissociations of MgOH2, then you have Mg2, then you have a strong base. All right, so we have another one. For example, we have a Li, for example, Li plus O2 to give Li2O, all right? again, because this one in group 1 and this is actually -2, we just change the number diagonally, right? So Li receives 2 from oxygen and 1 from lithium gives to oxygen 9, and then I have Li2O. All right, so what happened when I add Li2O into water? So Li2O, I add to water, it will give me LiOH plus H2. All right, so again, this one is actually strong base. Yeah, so it means that when I add lithium hydroxide into water, it will completely dissociate. Dissociates means that the ions of Li plus and OH minus is completely separated to give Li plus aqueous plus OH minus aqueous. Right? Now, how about the last one? So actually, I just want to tell you that we have a, let me just erase this one. So for example, I have another element, which is aluminium, which is in group 3 and period 2. So we have aluminium. Okay, aluminium, we react with oxygen, then you may have a consideration that aluminium is in group 3, so it will have plus 3 charge, and oxygen is in group 6, so it will have a -2 charge. So you just move this number diagonally, then you have Al2 because this is actually from oxygen, and then O3. Okay, so O3 is coming from the aluminium, right? So and then when I add Al2O3 into water, then it will give me AlOH3 plus hydrogen gas. So basically, this is actually weak base. Yeah, if we compare from left to right, so this actually you need to remember, right? So there are two things. Number one, from left to right, from left to right of your periodic table, yeah, of your periodic table, the basicity increases or basicity decreases. Or you can say oppositely, you can say that acidity increases. If the acidity increases, it means that the pH is smaller. The pH is even lower, right? So it means that uh, from left to right, it becomes more acidic. Number two, also, if we arrange these three, MgO, LiOH, and Al2O3 in terms of their strength of base, so we may say that I may have this arrangement. LiOH is stronger base compared to MgOH2, and then is also stronger base compared to AlOH3. Okay, so you have to remember this one. And then it means that this one's pH is very high. This is actually pH is very a bit low, yeah, not actually less than 7 because basically this one is still base. All right, number two, how about the trend from top to bottom? Okay, from top to bottom, the pH of the strength of base. So from top to bottom, okay, top to bottom, the pH is higher. It means that basicity increases. Basicity increase means that if you compare, for example, lithium hydroxide compared to cesium hydroxide, it means that cesium hydroxide has higher pH. So pH of CSOH2, pH of CSOH is stronger than pH of LiOH. Okay, so just for your information. Thank you.